So in this video we're going to talk about finding the sine and cosine values using the unit circle. So the first thing we need to understand, if you have a right triangle, sine and cosine are simply ratios between the lengths of the sides of a triangle. So if I have a right triangle with, we'll say theta is right there, then in a right triangle this is called the hypotenuse, and these are the legs. So in reference to the angle though, this would be the opposite leg because it's across from theta, and this would be the adjacent leg because it's next to theta. That's what adjacent means, is next to. So in our understanding of sine and cosine, cosine of theta, so the cosine of an angle is equal to the adjacent side divided by the hypotenuse. Likewise, the sine of an angle is equal to the opposite side divided by the hypotenuse. And last but certainly not least, tangent of theta is equal to opposite side divided by the adjacent side. And you may have heard this before, but there's a little acronym called SOHCAHTOA, which helps us remember that relationship. You can see how the S stands for sine, O stands for opposite, H is hypotenuse, and then cosine adjacent hypotenuse, and then tangent opposite adjacent. So that's just a little mnemonic device to help us to remember the relationships between sine, cosine, and tangent. So once we have that understood, then if we go back to the unit circle that we've been talking about, here's a unit circle. And if I'm trying to find my way around the unit circle, so let's say, for example, I want to take the cosine of 30 degrees. Well, in the previous video, we practiced finding out where we're at in the circle. So 30 degrees is going to be approximately about there. But what's important to notice is when I draw a 30-degree angle, if I drop a line from that point down to the x-axis, it forms a right triangle. And so this would be 30 degrees. And because it's a unit circle, we know this is 1. The length of the radius is 1. So really cosine is going to be the adjacent over hypotenuse, but since the hypotenuse is 1, cosine is just the adjacent side here. Now also, if you remember the previous video, we have these special triangles where if you have a 30, 60, 90 right triangle, and if the hypotenuse is 1, we know that the short side is 1/2 and the long side is rad 3/2. So that's what we have here, is a 30, 60, 90 triangle. So since we're looking for cosine, that would mean we're looking for the long side of a 30, 60, 90 triangle, and that would be rad 3/2. If we are trying to find the sine of 30 degrees, well, now we're talking about opposite over hypotenuse, and the hypotenuse is still 1. So it really ends up being just this length right here, and that would be 1/2, because it's the short side of a 30, 60, 90 triangle. And now you can see you can do this with any friendly angle. So for example, if I want to know what the cosine of 150 degrees is, well, 150 degrees is a multiple of 30 degrees, so we should be able to find it. So first of all, we just have to determine where we're at in the circle. We know that all the way around to this, to the negative x-axis is 180 degrees. So 150 degrees would be 30 less than that. So we draw a little triangle like that, or an angle like that. If you drop a line down to the x-axis, we form another triangle. And again, we know this is a 30, 60 right triangle, just like the one before. So both of these angles, 30 degrees and 150 degrees, have what is called the same reference angle because they make the same triangle. Notice in this one, you have a 30, in this one we have a 30-degree angle next to the origin, and notice in this one we have a 30-degree angle next to the origin. So we're using the same exact triangle, a 30, 60, 90 triangle, so the lengths are the same. This is 1, this is rad 3 over 2, and this right here is 1/2. And since I'm looking for cosine, that means I want the adjacent side, so the one adjacent to 30 degrees. So that's going to be rad 3 over 2 for sure. But notice also, because we're going to the left, and this, remember, this is just a normal XY plane, right? This is the x-axis. This is the y-axis. So we know when we go to the left of the x-axis, I'm sorry, when we go to the left of the y-axis, our values are negative. So that would tell me that this has to be a negative rad 3 over 2. And real quick, just so you can see the difference, if I wanted to take the cosine of 120 degrees, okay, 120 degrees is just 30 more than 90, so that's going to be in the same quadrant, but it's going to be a triangle that looks like this. And if I drop the side down, that's where the triangle comes from. Notice the reference angle for this one, the angle of the triangle that's closest to the origin. The reference angle for this one is going to be 60 degrees because 180 minus 120 would be 60. So that angle there is 60. So this is a standing up, this is a standing up 30, 60, 90 triangle. So we have it, blow this up a little bit. There's my 60-degree angle. And we know that that means this is going to be 1/2 and this is going to be rad 3 over 2. And since I'm looking for cosine, that means I want the adjacent side, and that is clearly 1/2 because it's the shorter side, but also I'm going to the left again, so that would make it a negative 1/2. So we could do a couple more of these if I want to know what the cosine of 330 degrees and say the sine of 210 degrees. Again, the first step is to figure out where I'm at in the unit circle. So 330 is just 30 back from 360, so that would put it right there. Drop my line to the x-axis, and once again a 30, 60, 90 triangle shows up. The reference angle, or the angle close to the origin, is 30 degrees. And so we know that, and we're looking for the adjacent side, which is clearly the longer side. So that would be rad 3 over 2. And I'm going to the right, so it would be positive. Sine of 210. So 210 is 30 degrees past 180, so that would put it right there. I draw my line up to the x-axis. Again, I have a 30, 60, 90 triangle show up. The reference angle is 30 again. This time I'm looking for the opposite side, which would be the little short side over here. That's 1/2. Notice also that it's going down. And we know on the xy plane, if we're going below the x-axis, then the y values are negative. So that means that this would be a negative value. We could also do this if we're talking about radians. So for example, if I want to know the sine of 5 pi over 6. Again, from the last video, we've been hopefully getting better at finding our way around the unit circle in radians and degrees. So 5 pi over 6, we know that that each quadrant is divided into 3 pi over 6s, because 2 pi divided by 2 pi divided by 12 is equal to pi over 6. And so really I'm just counting my way as we talked about in the other video. So this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is right there. We draw the little triangle down. We get a 30, 60, 90 triangle. And I'm looking for the opposite side, so we have a 30-degree angle here, that's the reference angle, then this up here would have to be 1/2. So sine of 5/6 is equal to 1/2.